So now we get another little integral here. We're going to try our luck with, I think we should try our luck with u subs. So we'll make u equal to 3 plus 4x. Okay, if that's the case, then the derivative of u would be equal to 4 times the differential of x. And if that's the case, then I have x to the third all over u to the 1/2, and I have a dx there, which can be, of course, I can say this is 1/4 du can be exchanged for a dx. I'm going to make that blue my little dictionary here, my u sub dictionary. That tells me that the dx can be exchanged for that many du's, for a 1/4 du. That would get me to this step. I could take out that 1/4 all the way to the outside. I have a u to the 1/2, I have x to the third, and I have du. And I have a mild problem, except here that where I have the mixture of the two variables. I have u's and x's. So how do we change it? Well, we query the dictionary again. The dictionary says that x, let me see here, make a little extension of the dictionary here. The dictionary says that x can be exchanged, well, 4x can be exchanged for u minus 3, or x can be exchanged for u minus 3 over 4. That's the exchange rate. So x to the third would of course be u minus 3 over 4 to the third. So this one becomes 1/4 integral of u minus 3 to the 4th to the third all over u to the 1/2 du, which of course becomes, I could take this into pieces and say, well, this would be 1/4 on the outside, and I can have u minus 3 to the third, and I have a 4 to the third there, and I have a u to the 1/2 du, and of course this comes out and I get 4 times 4 to the third integral of u minus 3 to the third all over u to the 1/2 du. Now of course this is just expanding a binomial using your algebra skills, and the strategy here would be to expand this is a long binomial and then separate this into a bunch of little fractions. So it would look something like this. This is 4 to the 4th integral. This would be u to the third plus u squared times negative 3, and that's of course times 3, plus 3 times u times negative 3 squared plus negative 3 to the third. All that over u to the 1/2 du. I'm using my excellent algebra skills to expand that binomial into a power of 3, or Pascal triangle, or whatever you call that. And now I'm going to separate this into a bunch of little fractions. That little fraction, that little fraction, that I'm going to have, since I have 4 terms on the numerator, I'll have 4 different little fractions. And it'll look something like this. It'll look like 1 over 4 to the 4th integral of u to the third over u to the 1/2 plus, I'm going to collect these, why not? I'll put negative 9 u squared to all over u to the 1/2. Here I have 3 times 3 times 3. That's going to give me 27 u all over u to the 1/2. And here I'll just have 27, well, I think I'm running out of screen, all over u to the 1/2 du. Nice, and that becomes 1 over 4 to the 4th integral. This becomes, I have u to the third up here, and u to the 1/2. Well, 3 minus a half, let's see how much is that. That's 2.5. So that becomes u to the 5/2 plus 9u. I got 2 up there, and I got to take away 1/2, so that means 3/2. This is negative. Plus 27. I have a u here, and I have u to the 1/2. This becomes u to the 1/2. Plus I have 27 and u to the 1/2. That's just 27 u to the negative 1/2 du. And now we just have a bunch of super easy integrals. They're all just the power rule. So 1 over 4 to the 4th times, I got to use the power rule, u, add a 1 to it, and then divide by the new exponent, and then you have negative 9. Yeah, the rest of this is pretty boring. 5/2 divided by 5/2 plus 27 u to the 3/2 divided by 3/2, and on and on and on. Yeah, really, the rest of that is boring. That's how you do that problem, and not so bad. It's just a u sub, and you should know your expansions here, your binomials, just basic algebra stuff. Alright, that was fun. Let's see if we can do it one more time. I think we have one or two more problems left.